you doing, cat? Silly girl. Hey, good morning. It's Wednesday, January 8th. I am Rob, that developer dad, and we are building um, applications using .NET. So yesterday I started working towards getting things set up with an API so that there's an interface into these administrative backend thingies. And I kind of thrashed around with the open API stuff. I eventually just gave up. I could find nothing in any of the documentation or anything like that that could lead me towards figuring out what I had done wrong. So I said, you know what? This is internal only. I don't need to sweat the open API documentation for this. I'll want to solve that before I build build an API that's meant to be consumed by other people, of course. But for now, I ain't gonna sweat it. Excuse me. So what we are going to start to do today is actually figure out the user experience and the flow through the systems that will need to happen when a customer wants to do various things in the application. Um, I have need of their actual customer ID coming in these webhook requests that are going to arrive, and the only way I can attach that to their account is by creating a new checkout session at Lemon Squeezy. So checkout belongs to a store and is associated with a variant. Okay. Custom price. The value is not null, blah, blah, blah. Product options. We don't want to override anything. Checkout options. Embed if true, show the checkout overlay. Media if false. Hide the product media, blah, 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 blah. Subscription preview. Background color, headings color, all this stuff. Checkout data. We need to provide the email address, which could be a challenge. A name, again, could be a challenge. We don't collect billing address information or tax numbers. There's no discount code, and we will need to pass that Entra ID in the custom data here. Let's flip over. I'm actually on the Lemon Squeezy API reference. Take a preview object. This contains blah, 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 blah. We will want preview. Currency, whatever, subtotal, discount total. Okay, gotcha. Expires at, created at, updated at, test mode, and URL. All right. So let's get started on this. So we're going to need a Lemon Squeezy API provider. And that is going to manifest as a resource access component. So let's add a new project. It will be a class library right here. And we're going to call it resource access / class library. Let's call it dev dot.sas admin dot store access dot abstractions. Is that how I've got those things listed out? I believe it is. And let's make sure it goes into the correct directory here. Should go in here. Yes. Open. Create the project. And there it goes. So here's that. Let's make sure it's in .NET 8. Are the other projects in here in 8? Yes, they are. Okay. We're also going to need to make some adjustments to the catalog items, but that's something we'll get to in a moment. All right, and we can call .NET 8 components from .NET 9 components. We just can't, I don't think we can do the reverse, or at least we can't do direct project or binary references. And to maintain architectural correctness, I'm going to add a new manager. So it's going to be a class library. And I'm going to call it devdad.sas.admin.StoreManager. And the StoreManager is going to hold, oh, I goofed. New project, class library, come on. Excuse me, slash. Come on, Rob. devdad.sasadmin.StoreManager. Let's make sure it goes in the right place. Here we go. Create the project. And I want to make sure that it created all of those things in actual subfolders instead of just spraying the files all over the host folders. We see we've got our store manager now. Let's just scooch that out. And we've got our store something. StoreAccess.Abstractions. Groovy. There's one more project we're going to need to add to resource access. And I'm going to add that now. Yet another class library. And it will be devdad.sas.admin.StoreAccess.LsApi. Let's make sure it's going in the right place. It appears to be. Open Sesame, create the project, and there it is. Let's go ahead and add on the StoreAccess.LsApi project. Let's add StoreAccess.Abstractions. We'll add that developer.ifx. And we will add SASAdmin IFX. So we've got those right away. Excuse me. StoreManager needs StoreManager StoreAccess abstractions. So there's that. It also needs SASAdmin IFX. And it also needs that developer.ifx. Cool. And let's save all of that stuff. Finally, while we're in here, let's go ahead and add project references to StoreManager, StoreAccess.Abstractions, and StoreAccess.LsApi. let's make sure I didn't add a reference to the concrete LsApi up here in the, okay, cool. That's all that needs for now. All right, start upgrade, we've got that. Let's 86 this weather forecast. Get lost. Oh, we do need to return the app from the extension method. All right. And this endpoint will be called from the application when a user clicks on an upgrade to paid plan button. It will send the basic information to the Store API, which will create a checkout session for that user and return the URL to the checkout page at the store provider so that the user can fill in their payment information, complete the transaction. Now I've started building out this create upgrade link request here. And that's just a DTO that the application over in the DM's familiar code is going to create and then pass in its API request over here. And we've got the HTTP context coming in. It doesn't really return anything. We will probably write some sort of, we're going to probably change the response type to this, but we'll get to that detail later. Right now, we need to build out the actual manager and the API access method. So I want to follow similar patterns as I have in my account manager. So I've got contracts and internals. I'm not likely to have many internals in here. So let's go ahead and add a new folder called contracts. We're going to add a new file. It's going to be an interface. And it's going to be StoreManager. There we go. Public interface StoreManager. It will inherit from iManager service. And let's make sure I've got, because it's been a while since I've stood up a new one of these. Okay, it just implements iManager service, which is one of those marker contracts. And we're gonna need a new class, start checkout request. Represents the data needed to send to a create checkout API request at our store provider. save. Now, there are some things that I do with request thingies. It wraps operation request of subscription action detail. So let's run back down here and add another class, new file, new checkout request, new checkout data. Come on, Rob. Class. There we go. This represents the data needed to start a new checkout session at Lemon Squeezy. Start checkout request represents the request to the store manager carrying the data to begin a new checkout session. And this guy inherits from operation request of new checkout data. Implement the abstract class. Operation name is request new checkout session. N, start checkout request, workload name, new checkout data is nullable, base workload name payload, very good. And I am going to add a public new checkout data. And we're going to do this the old-fashioned way, sort of, just by using, we're going to at least define explicit getters and setters, and there we go. Great. And workload name, new checkout data, yeah. And that's about all we need, I believe. Let's double check. Account manager, user quotas. Here we go. Let's take a look at this request data. Yeah, these are just helper methods. Subscription, okay. All right, and then we're going to need a response. And really, if it's successful, all we're getting back is a string with the URL. So we'll add a new class called start checkout response. It will operation result or operation response with a nullable string as its payload. There's that, operation request, it takes that, string payload, and that's really it. But what I'm going to do is I'm going to add a helper method or a helper property here. Public string checkout URL get payload set is that. Okay, and I believe that's about it. as far as setting up the basic contracts that we need. Because we'll be able to put any kind of errors or anything like that inside the response objects errors collection. Now, we're also going to need to define new file, interface, store API access, describes the behaviors provided by the StoreAccess component. Right now we have a single behavior that we care about. There will be more, but in terms of writing the least amount of code required to get this thing stood up, we have a single method. So I am going to check out request, new file, class, check out response, new file, class, check out data. There we go. And the request inherits from operation request of type checkout data. Did I not add? I didn't. I'm a silly goose. Let's add a project reference. We are going to need SaaSadmin IFX. We are also going to need that developer.ifx. Cool. Now we can import. There it is. Operation name will be invoke store API. Excuse me. Create checkout. I like that. There we go. Here's all this stuff. And then finally, I'm going to add just an accessor property that will type the payload and make it a little bit happier for me. Prop, checkout data. And I'm just going to call it checkout data. And because it's a pass-through, I'll jump up here and do these things. Payload, I have to make this nullable. Payload equals value, you silly goose. All right, there's that. Cool. Close that. Check out response. It is operation response of type string. Save. Got to generate the constructor. Prop string checkout URL. And this is going to be a discrete, or rather unique URL per customer per session. Get. We're just going to lambda over to payload. And for the set, we're going to lambda over to payload equals value. And we have to remember that this string might be null. And that's that. So here's iStoreAPI access. This guy is a iResource access service. And there is one more thing that we need to add, but we can't add that here because the configuration requirements for the Lemon Squeezy API may be different from the configuration requirements for, say, Stripe's API, although those, I believe, are probably going to converge over time because Stripe has purchased Lemon Squeezy. Excuse me. I'm going to keep the checkout object on screen here. Requests, responses, and I want to open the Getting Started API docs from Lemon Squeezy over here. Needs to be made over HTTPS. Cool. JSON API spec. All right. All API requests must be made over HTTPS to HTTPS API limits. Calls made over plain HTTP will fail. Of course they will. I would expect nothing else. These headers must be included. This is a implementation detail with a null origin header from the sandbox iframe and a Figma. Then you can use API cores anywhere.lemonsqueezy.com. API proxy URL instead. Okay. Uses API keys. I have a test mode key. Beautiful. And I need to get I'm going to need to obtain a bearer token. So, excuse me, goodness. Custom paginated queries, filtering, blah, blah, blah. Don't really care about that stuff. Related resources, nested queries. Do not care about those things. Let's look at authentication. Is there any more details about authentication here? No. All right. In here, class 1. We got to rename this to Lemon Squeezy API provider. That's fine. Cool, cool. It's going to inherit, or implement rather, iStoreAPI access. That's complaining. We got to bring that in. And we haven't added any methods to it yet. Ha! Task, checkout response, request, checkout async, and that's that. Let's add a little comment here. Creates a checkout session at Lemon Squeezy. If successful, a URL to the checkout page for the identified customer and product is returned, which can be used to open a new browser tab in the main application. Cool, cool? Cool. Now, let's go ahead and just pop that guy in there. Excuse me. I have a question for GitHub Copilot real quick. I have comments written against the interface and its operations that are implemented in the current class. I remember using some sort of tag in implementation comments to include inherit comments I've made on the interface, but I can't remember what those are. Inherit doc, beautiful. Can I add additional comments alongside inherit doc to clarify details about implementation of a component as well? Cool. So here's what we're going to do. So we've got the SummerL set up there. And it's inherit doc. cref. Remind me what I can do with the cref attribute on the inherit doc tag. Beautiful. So I can sysadmin StoreAccess.Abstractions .iStoreAccess. Beautiful. That's lovely. Implements StoreAccess for the lemon squeezy e-commerce API. And for this one, I can just do that because I don't really need to clarify the context or anything like that on the comment that I put here. Checkout request is a child of operation request with checkout data as its payload. returns a task, checkout response, checkout response is a child of operation response with a nullable string containing the end user checkout URL if the call is successful. Save all of this stuff. So there's StoreManager. We don't need to mess with that. Our API provider, we're going to need some stuff. Now, I do want to look at other resource access things, implementations to be specific. So here's my Azure table provider, not the rules access. I really ought to rip that out. I'm not using it anywhere yet. Let's take a look at user account access. So I've got options and I've got the actual table provider. So it uses a logger, options, and then this guy is created inside the constructor. All right, so up in StoreAccess.LsApi, I need to add a new class. LsApi options. Carries configuration data required to connect to the Lemon Squeezy API. And just for comparison's sake, right here it's just using a connection string. That's groovy. This will inherit from iService options or implement iService options. And I believe that's a marker interface. Yep. It just allows the reflection code inside my architectural framework to locate the actual configuration class to be used, bound, and injected into my implementation. Excuse me. We need use API keys, blah, 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 blah. Okay. Boogity boo, there's test mode. Here's the authenticated request example. Okay, it's using the API key as the bearer token. Cool. All right. Prop string base URL string.empty. I don't know why GitHub Copilot gets so eager to help sometimes, and it just says the wrong thing. API key is that. I think that's all she wrote. Test mode. test mode. Save. And Booleans instantiate as false. Save. Lemon Squeezy API provider, here we go. Save this. And private read-only. Options. Private read-only. iLogger. derp. Lemon Squeezy API provider is my logger. And there was one more thing I had over there. Oh yeah, that was the table client. Private read-only HTTP client factory. What are you complaining about? Maybe not I, but that? No, been a while, and they change it every couple of .NET versions. Let's ask Copilot. In .NET 9, .NET 8, I'm building a Web API access component. Need to, and I know I need to, inject an HTTP client or HTTP client factory into that component so that I can use the singleton factory throughout my application, throughout the subsystem. I cannot remember which interface I should inject into the concrete component implementation. Resource management issues, HTTP client factory. Socket exhaustion, HTTP client factory to create. Manage, okay, my service. Perfect. Okay, I'm already adding a non-typed HTTP client factory. When I create my app's ambient service provider, that implicitly, if I understand correctly, doing so implicitly registers the HTTP client factory for me. I can simply request the concrete HTTP client instance in my internal components constructor. If I'm understanding this correctly, I do not need to dispose of that HTTP client when my API access class falls out of scope. Explicitly dispose. I just want to clarify these points. Non-typed HTTP, blah, 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 blah. Factory manages the lifetime of the HTTP client instances it creates. Don't need to explicitly dispose of the HTTP client. Factory takes care of resource management for me, ensuring that connections are reused efficiently and properly disposed of when no longer needed. That is a thing of beauty. Pardon me. And the HTTP client factory that's ambient in the applications service provider manages all of my lifecycle nonsense. Thing of beauty. Just wanted to make sure. So I don't pull in an HTTP client factory. I pull in an HTTP client. There's that. And now we'll set up the constructor. It will accept LsApi options. Stop it. Let's do that stuff. I want to take a peek at the constructor for my user account table provider. Not the options, you silly goose. Here we go. It pulls in a logger factory. Okay. Not a logger. That's fine. Is my logger nullable? It is not. We need to make that nullable. Logger factory dot create logger for this. Cool. HTTP client equals HTTP client. Groovy. And I've got my options. Now, before the session this morning, before I started the session this morning, I actually put that API key into my web apps environment variable or .env file right here. I'm not going to click it, but that's where I put it. So how do we get all of this stuff talking to each other? And how do we get it building up correctly? Well, before we can do that, I'm putting the cart before the horse here. I got to run down here and actually create a StoreManager. It'll inherit StoreManager. We got to pull that guy in. Now, if I put any behaviors, I'm going to rename the file too. There we go. I don't think I've added any behaviors. I haven't. This is going to return a task, start checkout response. Start checkout async. Pass in the start checkout request. Yeah. Provides the use case orchestration. Provides the orchestration of resource access and compute, logic compute, services to perform activities against the online store service. And I'm going to disambiguate that. E-commerce service. If we switch to an alternative, to a different online, different e-commerce provider in the future, shouldn't need to do more than implement the StoreAccess contract against its API. And do the old switcheroo on the store provider. And we don't often change our backend database, although I've done it in the execution of these projects. However, as this grows and as it matures and so on and so forth, I might find it advantageous to move to a different e-commerce provider than Lemon Squeezy. Right now, they offer everything I need, including secure storage of payment details. They automatically calculate sales tax for whatever jurisdiction my customer is in and add that to the order. They also write the checks to those revenue services for me. I don't have to worry about a damn thing when it comes to sales tax by using Lemon Squeezy. I'm not paid to make this statement. This is just, I'm explaining why I chose them as a provider. And good morning, Mars. In the future, I may discover that there is a less expensive or a more feature rich or what have you. I might have some need. Lemon Squeezy did just get absorbed by Stripe. And even though they've said they have no intentions of altering how Lemon Squeezy works, it's 2025 and corporations don't really care about their customers anymore as long as the customers keep sending them money. So we'll see how that happens. I'm glad I'm not a corporation because I can care about my customers. I am my only shareholder. I don't even have shares. So yeah, so I can start the checkout. If I decide I need to switch over to a different e-commerce provider in the future, I can re-implement iStoreAccess against that company's API, and I shouldn't have to change very much in here at all. So that's pretty groovy. Let's come in here and implement, implement Z interface. I need to create some private read-only variables here. And I'm just going to change that to store access. Boop. Private read-only logger of StoreManager. And let's build my constructor. StoreManager needs that stuff. It's following my logger factory pattern. That's a thing of beauty. We'll get rid of these extraneous brackets. And we are about stubbed out. Now, I don't have all the properties that go into the checkout data. When I come back in the afternoon, we're going to fill in the property, or we're going to add the properties to checkout data. And there's one more thing that we have to do down here in the Lemon Squeezy specific API provider. And that is add a new folder called Lemon Squeezy Models. New file. And I'm going to call this class ls checkout rack. And a class ls checkout response. And then what we're going to do is we're going to add properties to the checkout request and the checkout response object to mirror what Lemon Squeezy expects. And then we're going to map between my incoming component model for the checkout data, checkout request, checkout response. We're going to map back and forth. So what this does is it gives us an abstraction layer between the rest of the application and whatever specific GUI the remote service provider expects. And so as Lemon Squeezy iterates on their API and makes changes and so on and so forth over there, all I need to do is change up the mapping and stuff, unless, of course, they add a new required bit of data that I'm not including in the stack, in which case I will need to make some additional changes, but that's okay. That's expected. We're minimizing those. If I were coding directly against the Lemon Squeezy API properties all the way out in the StoreManager, or expecting them on my API gateway, then I'd have to make changes throughout the entire stack and all of the subsystems. So by very carefully and very rigorously making sure that each component knows how to receive or receives data in the format that it expects, translates that data into the format that its dependencies expect, and then, of course, translates back from the dependency response to its local idiom, I effectively protect all of my components from changes in the others. And this is a very, very powerful technique. 10 out of 10, do recommend. And when we come back this afternoon, we're going to start filling out the Lemon Squeezy specific checkout request. Where are you? I just added you. You goose. I am such a goose. Here's the StoreManager. There it is. And is this the abstractions? Oh, that's the manager. You goofball. Here we are. Here's all the component specific stuff. So when we come back this afternoon, we're going to start working on this. And then we're just going to plumb all of that data. As we discover what's required out here, I'm just going to add that to the resource access models, and then I'll add it to the manager model, and then ultimately we'll add it to the API model. And then rather than writing extension methods, if I'm able to create a domain model that sort of describes all of those different models, I can create some auto mapping logic. leveraging the domain object mapper um, part of the framework that I built back in late November, early December, and we'll be able to talk through that. But I think that's what we'll start with this afternoon is getting these models defined and plumbed out through the stack. So until then, take care of yourselves and happy coding. Mars, it was great to see you even briefly. Thanks for the lurk. We'll hopefully see you again soon. I got a jet. I've got a call coming in about 20 minutes and I got to give my head a shake and so on and so forth. So I will talk to you all later. Take care.